Hello, I welcome you all. The problem reads, determine the force in each member of the truss, state whether the members are in tension or compression, set P equal to 8 kilonewtons. Right, this problem is coming from the Engineering Mechanics Statics textbook by R.C. Hibbeler. The geometry of this particular member is symmetrical about its axis. Okay, so that is one step. Let's check on the loading. I could have started directly. Okay, when you look at joint D, we already have a loading there and number of unknown at joint D are 2. So I would have gone directly to start working out or finding the member forces. But since I've realized that there is symmetry in this, which will make the work much easier. So geometrically it is symmetrical. Let me check on the loading. So for me to check on the loading, I'll need to find the support reactions. Drawing the free body diagram, I expect a reaction at support E, vertical reaction EY. I expect two reactions at the hinge A. This is AY and AX, right? And let's work out summation of moments. We start with A, take moments about A is equal to 0, and clockwise being our reference. And P is been given as 8 kilonewtons. Therefore, we have negative moment minus P by lever arm 8 plus EY equal EY by the lever arm, which is 4, so equal to 0. Therefore, our EY is going to be equal to 16 kilonewtons. Then summation of forces in the Y direction going up being our positive. We have AY plus EY minus 8 equal to 0. We've already found what EY is, so we just replace it there. Right? Therefore, our AY will be equal to minus 8 kilonewtons. Then finally, summation of forces in the x direction horizontally going to the right is our positive. We only have AX equal to 0. Alright, let's write these forces. AY is going to be equal to 8 kilonewtons. EY is equal to 16 kilonewtons. I didn't write this one. AY is supposed to be facing downwards. That's the reason that is why what that negative means there. This negative here, it means direction just changes. Right, so this is equal to 16 kilonewtons. Okay, where is my red? Alright, there we go. Alright, so with this, now when you look at the loading also, the loading shows symmetry about the same axis that goes through the support E vertically like so. So what does this mean? It means the reaction for the support, the member forces on the left hand side will be equal to the member forces on the right hand side. So we don't need to find all of them. We can just pick one side and we mirror it on the other side. Okay. So what I'm saying is the member force AB will be equal to the member force DC. The member force BE will be equal to the member force CE. And the member force AE will be equal to the member force DE. The only one that will have just a single force is BC. So this is what I'm saying. Member force AB, okay, in terms will be equal to member force DC. Member force BE will be equal to member force CE, and then member force AE will be equal to member force DE. The only one that will have a single force, member force, will be BC because it is being shared, okay, through this line of symmetry, right? It's being shared, okay. So because of this, we only consider, I'll only pick the right hand side. This is enough for me, and then I'll mirror the result on the other side. So I'll just focus on joint D and joint C. That's it. So let's go to joint D. Okay, let's draw our free body diagram at joint D. We have this force, which is a DC. Okay, we have components, and the other thing that I wanted to make up to also explain is the geometry. When you look at geometry of our truss, AE is equal to 4 meters, and so is ED, and BC is equal to 4 meters, and then we've been given the angle BAE is 60 degrees. If you are to apply your trigonometry here, realize that all the internal angles are 60 degrees, and all the lengths of the members, okay, all of them, they've got the same length. Okay, so length BE is equal to 4 meters, length CE is equal to 4 meters, length CD is equal to 4 meters, and the length AB is equal to 4 meters. Okay, right. So we get back to joint D. We are saying we have DC there, we have the applied load, which is 8 kilonewtons. What else? And then I'm assuming this one DE to be in compression, like so. This is DE. This angle here is 60 degrees. DC is going to have two components because it is at an angle. We expect DC like so there, and we expect another component the other side like that, right? This is DC sine 60, and then this is DC cos 60. All right. Okay, let's apply the equations of equilibrium. Let me delineate boundary here. So summation, I'll start with summation of forces in the y because we only have one unknown there. Summation of forces in the y direction going up being our reference positive. What do we have? We have DC sine 60 minus 8 equal to 0. Therefore, DC will be equal to 9.2376 kilonewtons, and we had assumed it to be in tension, and we found a positive value, therefore it's in tension. Then summation of forces in the x direction equal to 0. What do we have? We have minus DC cos 60 plus DE equal to 0. We've already found DC, which is this one here, so we just replace it there. Okay, so once we do that, then we have our DE. Okay, let me just wrap this here. We have our DE equal to 9.2376, right? 9.2376 cos 60. So this gives us a 4.6188 kilonewtons, and this one is we assumed it to be in compression, so it is in compression because we found a positive value. So found the member force DC. Okay, DC is 9.2376 and GE. So found two member forces. So let's move to joint C. Okay, let's move to joint C. We're on joint D, right? We move to joint C. Alright, so what do we have at joint C? We have a number of forces at joint C. We are assuming this one to be in tension, which is a BC or CB. And then we found DC already, which is in tension and is at an incline like that. This is DC, we already calculated it. Okay. Alright. And then we are assuming this one to be in compression. Okay, this one which is CE. Okay, this angle here is 60 and so is this angle here. Okay, so we're going to have components. We'll have components for CE. We'll have two components like so and another one like so. Okay, so let's label these ones. And then okay, so this is CE, so this one is CE, CE sine 60, then this one is CE cos 60. Okay, and then for DC we expect two reaction forces, two components, one in that direction like so, then the other one like so, to be coming down. This one DC will be equal to DC cos 60. This one will be DC sine 60. Right. We have all the information. We can now go straight away to start working out the problem. Mind you, we already have DC. We calculated it already. DC is 9.2376. So I will start with the vertical direction, summation of forces in the y equal to 0, going up in our reference. So we have CE sine 60 minus DC sine 60 equal to 0. Therefore, my CE is equal to DC, which is equal to, mind you, remember we calculated this, right? Here. This one here. Okay. We calculated that already. What was the value? It's 9.2376, and CE is, we assumed it to be in compression going towards the joint. This joint is joint C. This one is joint D. Okay. So this is in kilonewtons and this is going to be in compression, right? So we found that, then we apply summation of forces in the x direction like so. What do we have in the x direction? In the x direction, we have CE cos 60. What else? We have minus BC. What else? We have plus DC cos 60 equal to 0. We already have DC. Okay, we have DC, which is here. What else do we have? We have also CE, which we just calculated, which is this one here. Right? So we have that information, we just plug it in there and then we find what BC is. And then making BC subject of the formula, BC is 9.2376 cos 60 plus CE is also 9.2376 cos 60. What we find what we find is 9.2376 kilonewtons, and BC is in tension. Alright, so found this, so it means we are done. We can just now write down the information here. So we have CD. We said CD is equal to, we have CD, which is DC, no big deal how we call it. Okay, so we have DC, and then we found DC to be equal to 9.2376 kilonewtons, and this is in tension. And we said this is equal to AB, of course, because there is symmetry. And AB therefore will also be in tension, so it will be 9.2376 kilonewtons in tension. We also found DE, and our DE was equal to 4.6188 kilonewton, and is in compression. And DE is also going to be equal to AE, which is equal to 4.6188 kilonewton in compression. Okay, if you are not sure about symmetry, you need to solve all of them. Okay. What else? And then we have CE. We found CE. What was our CE? CE was equal to 9.2376 kilonewtons, and is in compression. And we said CE is equal to BE, therefore BE is also going to be equal to 9.2376 kilonewtons, also in compression. And then we found BC also, and BC was equal to 9.2376 kilonewtons, and is in tension. Alright, I guess we are done. I think we are done. This is the final solution. Remember forces for the truss, which is symmetrical, about this axis. Okay. So if the video is helpful, please give me a thumbs up, like my video, share my video, and continue subscribing to Benam Academy. Bye bye, and see you in my next screencast.